Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 4 units, side CD equals to 2 units. We also know that side CB equals to side AD, and we know that angle ABC, this angle equals to 90 degrees, angle DAB, this angle equals to 30 degrees, and we want to find out the area of this quadrilateral ABCD. So we will start with the first method. In the first method, we will do a construction from point D. We will draw perpendicular to AB. And we will define the touching point between the perpendicular from D to AB as point E. So this angle is a right angle, it equals to 90 degrees, and this angle is also a right angle that equals to 90 degrees. And we will define this line segment DE as A, that is to say the length of line segment DE equals to A units, and we will focus on the right triangle ADE. On the right triangle ADE, we know that sinus 30 degrees equals to ED over AD. We write it down. In the right triangle ADE, we know that sinus 30 degrees equals to DE over AD, but DE equals to A according to our definition, so we will substitute DE by A over AD, and sinus 30 degrees equals to 1 over 2, so we will substitute sinus 30 degrees by 1 over 2, and we will get that 1 over 2 equals to A over AD, here we will cross multiply equation number 1, and we will get that AD equals 2 times A. AD equals to 2A. So we can write down here that AD equals to 2A. But according to what is given us in the question, we know that AD equals to CB, so you can see here, AD equals to CB, And we already found out that AD equals to 2A. So from this equation, we will derive that CB also equals to A. CB equals to 2A. So we can write here that CB equals to 2A. CB equals to 2A. In the next step, we will do another construction. From point D, we will draw perpendicular to CB. And we will define the touching point from the perpendicular from point D and CB. We will define the touching point of the perpendicular from point D to CB as point F. So this angle is a right angle, that is to say it equals to 90 degrees, and this angle, it is also a right angle, that is to say it equals also to 90 degrees. And we will focus on quadrilateral ABFB, AEDFB or DFEB. In quadrilateral DFEB, we have three right angles, 1, 2, 3. The sum of three right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, we define angle EDF, this angle is angle X. So 270 degrees plus the size of the fourth angle, that is angle X, is the sum of all four angles of quadrilateral DFEB. In the next step, I will present to you a new rule, rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. I will write it down. The sum of the angles in any quadrilateral is equal to 360 degrees. I will read rule number 1 again. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. That is to say, the sum of the angles in quadrilateral DFEB equals to 360 degrees. It means that 270 degrees plus angle x, that is the sum of all four angles of quadrilateral DFEB, must be equal to 360 degrees according to rule number 1. So here we will subtract 270 degrees from this equation, and we will get that angle x equals to 360 degrees minus 270 degrees. That is to say, angle x equals to 90 degrees. So we found out that angle x is a right angle, it equals to 90 degrees. So we will substitute angle x by a right angle, as you can see from the drawing. All four angles of quadrilateral DFEB are right angles, they are equal to 90 degrees. And we also have rule number 2. According to rule number 2, any quadrilateral that has four right angles must be at least a rectangle if not a square. So if not a square, it must be a rectangle. I will read rule number 2 again. According to rule number 2, any quadrilateral that has four right angles must be at least a rectangle, if not a square. And because of the fact that our quadrilateral DFEB has four right angles, we will relate to quadrilateral DFEB as a rectangle. So quadrilateral DFEB is a rectangle according to rule number 2. So we will relate to quadrilateral DFEB as a rectangle. It is true according to rule number 2. And we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. I will read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of our rectangle DFEB are equal to each other. It means that ED equals to FB. Rectangle DFEB DE equals to FB. Again, DE equals to FB. According to rule number 3. I repeat again, DE equals to FB in rectangle DFEB according to rule number 3. But we have already defined DE as A, so we can write here that DE equals to A according to our definition. And from this equation, we will derive that FB also equals to A. FB also equals to A. What is the size of CF? The size of CF equals to CB minus FB. I will repeat again. From the drawing, you can easily see that CF equals to CB minus FB. CF equals to CB minus FB. That is to say, CF equals to CB is equal to 2A minus FB is equal to A. So CF equals to 2A minus A is A, so we found out that CF equals to A. CF equals to A. In the next step, we'll join together points D and B by a straight line. And we will prove that triangle TFB congruent to triangle DCF. I'll repeat again, we will prove that triangle DFB, this triangle, congruent to triangle DFC, this triangle. So why those two triangles congruent to each other? First of all, we know that FB equals to FC equals to A. I'll repeat again. FB equals to FC equals to A. We also know that those two angles, they are equal to each other, they both equal to 90 degrees. So angle DFB, this angle, equal to this angle, that is angle DFC. And both angles are right angles, that is to say they are equal to 90 degrees. I'll repeat again. Angle DFB equals to angle DFC, and they are both equal to 90 degrees, they are right angles. And we also have a common side. DF is a common side, it belongs to both triangles, so DF equals to itself. DF equals to DF is a common side that belongs to both triangles. I'll repeat again, DF equals to DF is a common side that belongs to both triangles. So actually, we proved that triangle DFB congruent this is the side of congruent to triangle DFC, according to side angle side rule. I'll repeat again. We prove that triangle DFB congruent to triangle DFC according to side angle side rule. So, what is side angle side rule? Side angle side rule is that if you prove that two sides and the angle between those two sides in one triangle congruent to two sides and the angle that is located between those two sides in the other triangle, you prove that those two triangles congruent to each other according to side angle side rule. And we proved that those two sides and the angle that is located between those two sides, that is to say this right angle in triangle DFB, congruent to those two sides and the right angle that is located between those two sides, that is to say this angle in triangle DFC. Therefore we proved that those two triangles congruent to each other according to side angle side rule. And from the fact that those two triangles congruent to each other, we will conclude that DC equals to DB. DC equals to DB. DC equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say DC and DB, will be equal to each other. But according to what is given us in the question, DC equals to 2 units. So we can write here that DC equals to 2 units, according to what is given us in the question, and from this equation, we will derive that dB also equals to 2 units. dB also equals to 2 units. So we can write here that dB equals to 2 units. In the next step, I will present to you a new rule or a new law, and we will implement the new rule that I will present to you in triangle DAB. So the new rule or the new law is the law of cosines. And the law of cosines is true in any triangle. So I can write down that in any triangle, if we have triangle ABC, that could be any triangle, so this is triangle ABC. And we know that side AB of this triangle, this side is equal to A units in its length. Side BC of this triangle equals to B units in its length. And side AC of this triangle equals to C units in its length. Then, according to the law of cosines, and we also know that the angle between side AB and side BC is angle theta, this angle is angle theta. Then, according to the law of cosines, A square plus B square minus 2 times A times B times cosine theta equals to C square. Again, A square plus B square minus 2 times A times B times cosine theta equals to C square. So here we will subtract C square from this equation, and we will add to this equation 2 times AB cosine theta, and we will get that A square plus B square minus C square equals to 2 times A times B times cosine theta. Here we will divide this equation by 2 times AB, and we will get that cosine theta equals to A square plus B square minus C square over 2 times AB. Okay, so this equation is true in any triangle. Cosine theta equals to A square plus B square minus C square over 2 times AB. So we will implement the law of cosines in our triangle ADB. This triangle ADB. So I will copy this triangle in a new page, and we will implement the law of cosines in this triangle ADB. So this is triangle DAB. We know that AD equals to 2A, DB equals to 2 units, and AB equals to 4 units, and angle DAB, this angle equals to 30 degrees. So according to the law of cosines, in triangle DAB, cosine 30 degrees will be equal to 2A square plus 4 square minus 2 square over 2 times 2A times 4. Okay. Here 2 times AB is 4 times AB. 4 square is 16 and minus 2 square is minus 4. 16 minus 4 is 12. Over 2 times 4 is 8. 8 times 2a is 16a. And cosine 30 degrees is square root of 3 over 2 equals to 4a squared plus 12 over 16a. Here we will multiply this equation by 16a and we will get that 16a times square root of 3 over 2 equals to 4a squared plus 12. 16 over 2 is 8. So in this side of the equation we will get that 8 times square root of 3a equals to 4a squared plus 12. So here we will divide this equation by 4. 8 over 4 is 2, so it is 2 times square root of 3 times a. That equals to 4 over 4 is 1, so here what is left is a squared plus 12 over 4 is 3. So here we will subtract 2 times square root of 3a from this equation and we will get that a squared plus 3 minus 2 times square root of 3 times a equals to 0. Here we will substitute 3 by square root of 3 square and we will get that a square plus square root of 3 square, that is actually 3, minus 2 times a times square root of 3 equals to 0. So here, this equation is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. So according to this trigonometric identity, we can change our expression to a minus b squared that equals to 0. In our specific expression, a equals to a and b equals to square root of 3. So a minus b squared in our specific expression will be equal to a minus square root of 3 squared that equals to 0, we will take a root out of this equation and we will get that a minus square root of 3 equals to 0. Because of the fact that the square root of 0 is 0. So we got that a minus square root of 3 equals to 0. Here we will add square root of 3 to this equation. And we will get that a equals to square root of 3 units. So here we can write down that a equals to square root of 3 units. Here also a equals to the square root of 3 units. And also here a equals to square root of 3 units. Now it is very easy to find out the area that we are looking for, the area of quadrilateral ABCD, this quadrilateral. Because the area of quadrilateral ABCD here the squared brackets is the sign for the area. It means the area of quadrilateral ABCD will be equal to the area of the right triangle, triangle ADE, this right triangle, plus the area of rectangle DFEB, this rectangle, plus the area of the right triangle, triangle CFD, this triangle. I will repeat again, the area that we are looking for, it is to say the area of quadrilateral ABCD, will be equal to the area of the right triangle, triangle ADE, plus the area of rectangle DFEB, plus the area of the right triangle, triangle CFD. So the area of triangle ADE, this triangle, will be equal to the base of the triangle that is AE, times the height to the base that is DE, over 2. So we found out that the area of the right triangle, triangle ADE, will be equal to the base that is AE times the height to the base that is DE over 2, and the area of this rectangle DFEB will be equal to here the EB times DE. Okay, and the area of the right triangle, triangle DFC will be equal to the base DF times the height to the base that is CF over 2. Again, the area of the right triangle CFD equals to the base of the triangle that is DF times the height that is CF over 2. But first of all, we will focus on the right triangle DEF, and we will implement the Pythagoras theorem on this right triangle DEF. According to the Pythagoras theorem, in the right triangle DEF, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, DE square plus EB square equals to DB square I will repeat again. In the right triangle DEF, according to the Pythagoras theorem, PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, DE square plus EB square equals to DB square. Here DE equals to square root of 3, so DE square is square root of 3 square of 3 square is 3, plus EB square is EB square. This is the missing variable, so we'll leave it as it is, equals to DB square. DB equals to 2, so DB square is 2 square, 2 square is 4. So we found out that 3 plus EB square equals to 4. We will subtract 3 from this equation and we will get that EB square equals to 4 minus 3 is 1. We will take a root out of this equation and we will get that EB equals to the square root of 1. The square root of 1 is 1. So we found out that EB equals to 1. And because of the fact that the opposite sides of a rectangle are equal to each other, it means that EB equals to DF, but EB equals to 1, so DF will be also equal to 1. And what is the value of AE? AE equals to AB minus EB. AB minus EB equals to AE. Let's repeat again. AE equals to AB minus EB. So AE equals to AB is 4 units and EB is 1, so AE equals to 4 minus 1 is 3. So we found out that AE equals to 3 units. Here AE equals to 3 units. Now we will continue to calculate the area of quadrilateral ABCD. We found out that the area of quadrilateral ABCD equals to the area of triangle ADE and the area of triangle ADE is AE. AE is 3 units times DE. DE is square root of 3 over 2. So the area of the right triangle ADE equals to 3 times square root of 3. Here it is square root of 3. So DE is square root of 3. So the area of the right triangle ADE equals to 3 times square root of 3 over 2 plus the area of rectangle DFEB. The area of rectangle DFEB equals to EB times DE. EB is 1 and DE is square root of 3, so the area of rectangle DFEB equals to square root of 3 square units and plus the area of the right triangle CFD and the area of the right triangle CFD equals to DF. DF is 1 times CF. CF is square root of 3 divided by 2. Okay, so the area of the right triangle CFD equals to square root of 3 over 2. Here we will multiply square root of 3 by 2 and then we will divide it by 2 in order to have a common factor with the other two expressions. And then we will take out a common factor of square root of 3 over 2 out of these three expressions. And we will get that square root of 3 over 2 is the common factor that we took out. So what is left inside the brackets after we took from this expression square root of 3 over 2, what is left, it is actually 3. And what is left from this expression after we took from it a common factor square root of 3 over 2, what is left, it is actually 2. And what is left from this expression after we took from it square root of 3 over 2 as a common factor, what is left, it is actually 1. So here we got the square root of 3 over 2 times 1 plus 2 is 3, 3 plus 3 is 6. And 6 over 2 is 3, 3 times square root of 3. So the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. I'll repeat again. The area of quadrilateral ABCD according to the first method equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. So we finish with the first method. In the next step, I will present to you how to find out the area of this quadrilateral ABCD according to the second method. In the second method, We will do another construction. From point A, we will draw perpendicular to AB. So this angle will be a right angle, that is to say it will be equal to 90 degrees. And from point C we will draw perpendicular to CB. So this angle will be a right angle, that is to say it will be equal to 90 degrees. We will define the intersection point between the perpendicular from A and the perpendicular from C as point E. Actually, we created quadrilateral ABCE, and in quadrilateral ABCE we have three right angles, 1, 2, 3. The sum of three right angles is 90 times 3 is 270 degrees, plus the size of this angle, angle AEC, that will define as angle X. So actually, the sum of those four angles, that is to say 270 degrees plus angle X, must be equal to 360 degrees, according to rule number 1, that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract 270 degrees from this equation, and we will get that angle X equals to 360 degrees minus 270 degrees, that is to say angle X equals to 90 degrees. So we found out that angle X is a right angle. It equals to 90 degrees. From the drawing you can see that quadrilateral ABCE has four right angles. All of its angles are right angles. Therefore we will relate to quadrilateral ABCE as a rectangle according to rule number 2. Quadrilateral ABCE is a rectangle according to rule number 2, that any quadrilateral that has four right angles must be at least a rectangle. So quadrilateral TSEB is a rectangle according to rule number 2. And we also have rule number 3 that states that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle ABCE are equal to each other. It means that AB equals to EC. Again, AB equals to EC. According to rule number 3. That the opposite sides of a rectangle are equal to each other, but it is given as the question that AB equals to 4 units. AB equals to 4 units. From this equation, we will derive that EC also equals to 4 units. EC equals to 4 units. Here EC equals to 4 units. Likewise, according to rule number 3, CB equals to AE. CB equals to AE according to rule number 3. And if we define CB as X, so here CB equals to X, from this equation we will derive that AE also equals to X, AE equals to X, but because of the fact that CB equals to AD according to what is given us in the question, CB equals to AD and CB equals to X according to our definition. From this equation, we will derive that AD also equals to X, AD equals to X, here AD equals to X, and what is the size of angle EAD? The value of angle EAD will be equal to 90 degrees. Angle EAD is 90 degrees minus angle DAB, that is 30 degrees. So 90 degrees minus 30 degrees is the size of angle EAD. That is to say, the size of angle EAD is 90 degrees minus 30 degrees is 60 degrees. So we found out that angle EAD equals to 60 degrees. In the next step, we will join points E and D together by a straight line. And we will join points D and B together by a straight line. I will copy triangle AED in a new page and we will analyze triangle AED. Okay. So I copied triangle AD in this page. As you can see, angle EAD, this angle of triangle EAD equals to 60 degrees, and we also know that AE equals to AD equals to X. So we know that in front of equal sides in the triangle there are equal angles. Therefore, in front of those two equal sides, they are equal to each other, they are both equal to X. So in front of those two equal sides, there are equal angles. In front of those two equal sides, we have those two angles, and those two angles must be equal to each other. Okay, those two angles must be equal to each other. So if this angle is angle y, then this angle must be also equal to angle y because of the fact that those two angles are equal to each other. And we know that the sum of the angles in any triangle equals to 180 degrees. And especially in triangle AED, the sum of its angles must be equal to 180 degrees. That is to say, angle y plus angle y plus 60 degrees must be equal to 180 degrees. Y plus y is 2y plus 60 degrees must be equal to 180 degrees. Here we will subtract 60 degrees from this equation and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. We will divide this equation by 2 and we will get an angle y equals to 180 degrees over 2, that is to say angle y equals to 60 degrees. We found out that angle y equals to 60 degrees, so we will substitute angle y by 60 degrees. This angle equals to 60 degrees, and this angle also equals to 60 degrees. So we actually found out that triangle AED is an equilateral triangle. And in any equilateral triangle, all the sides are equal to each other. So if AE equals to x, then ED will be also equal to x. So in the original drawing, we can also write down that ED equals to x. This angle equals to 60 degrees, and this angle will be also equal to 60 degrees. What is the value of angle DEC? The value of angle DEC will be equal to 90 degrees, that is actually the value of angle AEC, minus the value of this angle, that is angle AED, that equals to 60 degrees. So 90 degrees minus 60 degrees is 30 degrees, and it is the value of angle DCED. Okay? If we subtract 90 degrees from this angle, we will get this angle that is actually angle DEC, that will be equal to 30 degrees. In the next step, we will prove that triangle ABD, this triangle, can go into triangle EDC, this triangle. Triangle ADB, this triangle, can go into this triangle, triangle EDC. So why those two triangles can go into each other? First of all, we know that AB equals to EC equals to 4 units. I'll repeat again. AB equals to EC equals to 4 units. In addition, we know that those two angles, they are equal to each other, they are both equal to 30 degrees. That is to say, angle BAD, this angle, equals to this angle that is actually angle CED. And both angles are equal to 30 degrees. I will repeat again. angle BAD equals to angle CED equals to 30 degrees. And we also know that AD equals to ED equals to X. AD equals to ED equals to X. So we actually proved that triangle ADB congruent to triangle EDC according to side angle side rule. I will repeat again. We actually proved that triangle ADB congruent to triangle EDC according to side angle side rule. Here those two sides and the angle between them, that is to say this angle in triangle ADB congruent to those two sides and the angle between them, that is to say this angle in triangle EDC. Therefore we prove that those two triangles congruent to each other according to side angle side rule. And from the fact that those two triangles congruent to each other, we will conclude that CD equals to DB. CD equals to DB. I repeat again. CD equals to DB according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles congruent to each other. Therefore, the corresponding sides, that is to say CD and DB, will be also equal to each other. But CD equals to 2 units. It is given us in the question. CD equals to 2 units according to what is given us in the question. From this equation we will derive that DB also equals to 2 units. DB equals to 2 units. In the next step I will copy triangle ADB in a new page and we will implement the law of cosines on this triangle ADB. Okay? So this is triangle ADB that I copied from the original drawing, and we will implement the law of cosines in this triangle ADB. According to the law of cosines in this triangle, we will get that cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4. X squared plus 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12, over 2 times 4 is 8, 8 times x is 8x, and cosine 30 degrees is square root of 3 over 2 equals to x squared plus 12 over 8x. Here we will multiply this equation by 8x and we will get that square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4. So we will get in this side of the equation that 4 times square root of 3 x equals to x squared plus 12. I'll repeat again. We got that 4 times square root of 3x equals to x plus 12. We will subtract 4 times square root of 3x from this equation, and we will get that x squared plus 2f minus 4 times square root of 3x equals to 0. Here 12, it is actually 2 times square root of 3 squared, so we will substitute 12 by 2 times square root of 3 squared. So x squared plus 2 times square root of 3 squared, that is 12, minus 2, we will substitute 4 by 2 times 2, so it will be 2 times x times 2 times square root of 3, that equals to 0. This equation is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, this expression a equals to x, b equals to 2 times square root of 3. So we can substitute our expression by a minus b squared according to this algebraic identity. So in our expression a minus b squared, it is actually a is x minus b is 2 times square root of 3 squared equals to 0. Here we will take a root out of this equation and we will get that x minus 2 times square root of 3 equals to 0 because of the fact that the square root of 0 is 0. We will add 2 times square root of 3 to this equation and we will get that x equals to 2 times square root of 3 units. So we can write here that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units. X equals to 2 times square root of 3 units. And also here x equals to 2 times square root of 3 units. Now it is very easy to calculate the area of our quadrilateral ABCD, because of the fact that the area of quadrilateral ABCD will be equal to the area of triangle ADB plus the area of triangle BDC. So I will write it down. The area of quadrilateral ABCD will be equal to the area of triangle ADB, this triangle, plus the area of triangle DBC, this triangle. I repeat again. The area of quadrilateral ABCD will be equal to the area of triangle ADB plus the area of triangle DBC. In order to find out the area of triangle ADB, we will draw perpendicular from point D to AB. We will define the touching point. So this angle is 90 degrees, and this angle will also equal to 90 degrees. So we will define the touching point between the perpendicular from D to AB as point S. We will define line segment DS as H, abbreviation for the height. So, and we will focus on the right triangle ADS. On the right triangle ADS, sinus 30 degrees equals to edge over x, that is 2 times square root of 3. I repeat again. In the right triangle ADS, sinus 30 degrees equals to edge over 2 times square root of 3, and sinus 30 degrees is 1 over 2. Sinus 30 degrees is 1 over 2. 1 over 2 equals to edge over 2 times square root of 3. Here we will multiply this equation by 2 times square root of 3, and we will get that edge equals to 2 times square root of 3 over 2. 2 over 2 is 1, so we got that edge equals to square root of 3 units. So we can write here that edge equals to square root of 3 units. Now it is very easy to find out the area of this triangle ADB. The area of triangle ADB will be equal to the base of the triangle, that is actually AB, times the height to the base, that is H, over 2. I'll repeat again. The area of triangle ADB equals to AB times H over 2. Here AB is 4, H is square root of 3 over 2, so the area here 4 over 2 is 2. So the area of triangle ADB will be equal to 2 times square root of 3 square units. Again, the area of triangle ADB equals to 2 times square root of 3 units. And the only thing that is left to do is to find out the area of triangle DBC. The area of triangle DBC equals to, we'll find out the area of triangle DBC by using a special formula. First of all, we'll calculate the semi-perimeter of this triangle DBC. The semi-perimeter of any triangle is equal to the perimeter over 2, and the perimeter of this triangle is 2 plus 2 plus 2 times square root of 3. Again, the semi-perimeter of triangle DBC is 2 plus 2 plus 2 times square root of 3, and if we divide the semi-perimeter by 2, we will get if we divide the perimeter that is 2 plus 2 plus 2 times square root of 3 by 2, we will get the semi-perimeter. So we will divide the perimeter by 2, and this will give us the semi-perimeter. It is actually 2 plus 2 is 4, plus 2 times square root of 3 over 2. 4 over 2 is 2, and 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle DBC equals to 2 plus square root of 3 units, and the area of triangle DBC will be equal to the square root of S times S minus A times S minus B times S minus C. Here S is the semi-perimeter, and the semi-perimeter equals to 2 plus square root of 3 units, and A equals to 2, B equals to 2, and C equals to 2 times square root of 3. They are the side lengths of the triangle. So we will put the data inside this equation, and we will find out the area of triangle DBC. The area of triangle DBC will be equal here to the square root of S is 2 plus square root of 3 units, S minus A is 2 plus square root of 3 units minus 2 is square root of 3 units, S minus B is the same result because it is also A also equals to B equals to 2, so 2 plus square root of 3 minus 2 is square root of 3 times S minus C. S is 2 plus square root of 3 and C is 2 times square root of 3, so 2 plus square root of 3 minus 2 times square root of 3 is 2 minus square root of 3. Square root of 3 times square root of 3 is 3. 2 plus square root of 3 times 2 minus square root of 3. We'll find out the value of this expression by using the trigonometric identity, by using the algebraic identity that states that A plus B times A minus B equals to A squared minus B squared. Here A is 2, so A squared is 4, minus B squared. B is square root of 3, so square root of 3 squared is 3. 4 minus 3 is 1. 1 times 3 is 3. So we found out that the area of triangle DBC equals to square root of 3 square units. therefore, the area of quadrilateral ABCD, the area of quadrilateral ABCD will be equal to the area of triangle ADB plus the area of triangle DBC. We've already found out that the area of triangle ADB is 2 times square root of 3 units, plus the area of triangle DBC, the area of triangle DBC is square root of 3 units, 1 times square root of 3 units. So 2 times square root of 3 units plus 1 times square root of 3 units is 3 times square root of 3 units. So we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. We finished with the second method. Now I will summarize the lecture. Actually, we found out the area of quadrilateral ABCD by using 2 different methods. The first method we drew perpendicular from point D to AB. So this angle is 90 degrees, this angle is 90 degrees, and we defined the touching point between the perpendicular from D to AB as point E. Then we focused on the right triangle ADE. On this right triangle ADE, we know that sinus 30 degrees equals to AD equals to DE over AD. Actually, we defined DE as A, so we can substitute DE by A. So sinus 30 degrees equals to A over AD. Sinus 30 degrees is 1 over 2, and 1 over 2 equals to A over AD. We cross-multiplied the equation number 1, and we found out that AD equals to 2A. So here we can write down that AD equals to 2A, and because of the fact that AD equals to CB according to what is given us in the question, so AD equals to CB according to what is given in the question from one side, and from the other side we found out that AD equals to 2A. From this equation we will derive that CB also equals to 2A, CB also equals to 2A, here CB equals to 2A, and then I presented to you, then we actually drew perpendicular from point D to CB, so this angle equals to 90 degrees and this angle equals to 90 degrees, and we defined the touching point from the perpendicular from D to CB as point F. Then I presented to you a new rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So if we focus on quadrilateral DFEB, according to rule number 1, the sum of its angles must be equal to 360 degrees. Quadrilateral DFEB has three right angles, 1, 2, 3. The sum of three right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle x. In total, those four angles must be equal to 360 degrees, that is to say 270 degrees, plus the size of angle x must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation and we got that angle x equals to 360 degrees minus 270 degrees equals to 90 degrees. So we found out that angle x is a right angle, it equals to 90 degrees. So this angle is a right angle. Therefore, all angles inside quadrilateral DFEB are right angles. And we have rule number 2. According to rule number 2, any quadrilateral that has four right angles must be at least a rectangle, if not a square. And because of the fact that quadrilateral DFEB has four right angles, we will relate to quadrilateral DFEB as a rectangle. It is true according to rule number 2. Okay, so quadrilateral DFEB is a rectangle, and we have also rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle DFEB are equal to each other. It means that DE equals to FB. DE equals to FB according to rule number 3. But DE equals to A according to our definition. DE equals to A. So from this equation we will derive that FB also equals to A. Here FB equals to A. What is the value of CF? CF equals to CB minus FB. CF equals to CB minus FB. So CF equals to CB, that is 2A, minus FB, that is A. So CF equals to 2A minus A. 2A minus A is A. So we found out that CF equals to A. Then we join together points D and B by a straight line. And we proved that those two triangles can go into each other. We actually proved that triangle DFB can go into triangle DFE. So why those two triangles can go into each other? First of all, FB equals to FC equals to A. FB equals to FC equals to A. Angle DFB equals to angle DFC equals to 90 degrees. Those two angles are right angles. That is to say they are equal to 90 degrees. Therefore they are equal to each other. And we also have a common side. DF equals to DF is a common side that belongs to both triangles. Therefore we proved that triangle DFB can go into triangle DFC according to side angle side rule. So what is side angle side rule? If two sides and the angle between those two sides in one triangle can go into two sides and the angle between those two sides in another triangle, then the two triangles can go into each other according to side angle side rule. And we actually proved that those two sides and the angle between them in triangle DCF can go into those two sides and the angle between them in triangle DFB. Therefore, we proved that those two triangles can go into each other according to side angle side rule. And from the fact that they can go into each other, we will conclude that DC equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. DC equals to DB. But according to what is given us in the question, DC equals to 2 units. DC equals to 2 units. From this equation we will derive that DB also equals to 2 units. DB equals to 2 units. Okay? Then I presented to you a new law that is actually the law of cosines. In any triangle, if AB is the length of If A is the length of side AB, B is the length of side BC, and C is the length of side AC, then according to the law of cosines, A squared plus B squared minus 2 times AB cosine theta equals to C squared. Here we subtracted c squared and added 2 times ab cosine theta to this equation, and we got that a squared plus b squared minus c squared equals to 2 times ab cosine theta. We divided this equation by 2 times ab, and we got that cosine theta equals to a squared plus b squared minus c squared over 2 times ab. So in any triangle, cosine theta equals to a squared plus b squared minus c squared over 2 times ab. And we will implemented the law of cosines on our triangle DAB. So I copied triangle DAB in a new page, and we implemented the law of cosines in this triangle DAB. So this is triangle DAB. We know that DA equals to 2A, AB equals to 4 units, DB equals to 2 units, angle DAB equals to 30 degrees. According to the law of cosines, cosine 30 degrees equals to 2a squared plus 4 squared minus 2 squared over 2 times 2a times 4. 2a squared is 4a squared, 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12, 2 times 4 is 8, 8 times 2a is 16a, cosine 30 degrees is square root of 3 over 2, and it equals to 4a squared plus 12 over 16a. We multiplied this equation by 16a, and we got that 16a times square root of 3 over 2 equals to 4a squared plus 12. 16 over 2 is 8, so in this side of the equation we will have 8 times square root of 3 times a equals to 4a squared plus 12. We divided this equation by 4, and we got that 8 over 4 equals to 2, so in this side of the equation we will have 2 times square root of 3 times a equals to 4 over 4 is 1, so here we will have a squared, and 12 over 4 is 3, so in conclusion we got that 2 times square root of 3 times a equals to a squared plus 3. We subtracted 2 times square root of 3a from this equation, and we got that a squared minus a squared plus 3 minus 2 times square root of 3a equals to 0. We know that that 3 is square root of 3 squared, so we substitute 3 by square root of 3 squared, and we got that a squared plus square root of 3 squared minus 2 times a times square root of 3 equals to 0. So this expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, a equals to a and b equals to square root of 3. So we can substitute our expression to a minus b squared according to this algebraic identity. In our expression, the meaning of a minus b squared, it is actually a is a and b is square root of 3, so a minus b squared will be equal to a minus square root of 3 squared, that equals to 0. Here we took a root of this equation, and we got that a minus 3 equals to 0, because of the fact that the square root of 0 is 0. A minus 3 squared equals to 0. We added square root of 3 to this equation, and we found out that a equals to square root of 3. So here we can write down that a equals to square root of 3. Here also equals to square root of 3. Here also equals to square root of 3 units. And then we focus on triangle, the right triangle DEB, and we implemented the Pythagoras theorem on the right triangle DEB. On the right triangle DEB, on the right triangle, it is actually the right triangle DEB. We know that DE squared plus EB squared equals to DB squared. PT is the Pythagoras theorem. DE is equal to 3. DE squared is equal to 3 squared. Square root of 3 squared is 3. EB squared is EB squared. DB equals to 2, so DB squared is 2 squared. 2 squared is 4. So we got that 3 plus EB squared equals to 4. We subtracted 3 from this equation and we got that EB squared equals to 4 minus 3 is 1, so EB squared equals to 1. We took a root out of this equation and we got that EB equals to the square root of 1. The square root of 1 is 1. So we found out that EB equals to 1. And because of the fact that the opposite sides of a rectangle are equal to each other, DF will be also equal to 1. What is the value of AE? AE equals to AB minus EB. AE equals to AB minus EB. AB is 4, EB is 1. So AE equals to 4 minus 1, that is to say AE equals to 3 units. AE equals to 3 units. And now it is very easy to find out the area of quadrilateral ABCD. The area of quadrilateral ABCD will be equal to the area of triangle ADE plus the area of rectangle DFEB plus the area of the right triangle CFD. The area of the right triangle ADE is the base of the triangle that is actually AE, that is 3, times the height, that is DE, that equals to square root of 3 units over 2. So it is 3 times square root of 3 over 2, plus the area of rectangle DFEB, that is actually DE times FB. DE is square root of 3, and EB is 1, so it is actually square root of 3 square units, plus the area of the right triangle CFD. The area of the right triangle CFD equals to the base, that is DF, times the height, that is CF, over 2. DF is 1, CF is square root of 3, so it is 1 times square root of 3 over 2. And here we multiplied square root of 2 by 2, and then we divided by 2 in order to have a common factor of the other two expressions. So square root of 3 over 2 is a common factor for these 3 expressions. And what is left inside the brackets from this expression after we took from it square root of 3 over 2, what is left? It is actually 3. And from this expression we left only with 2, and from this expression we left only with 1. So square root of 3 over 2, 3 plus 2 is 5, 5 plus 1 is 6. So we got that square root of 3 over 2 times 6. 6 over 2 is 3. So in conclusion, we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units according to the first method. Then I presented to you how to find out the area of quadrilateral ABCD using the second method. In the second method, we did another construction. Here, from point A, we draw perpendicular to AB, so this angle is a right angle. And from point C, we draw perpendicular to CB, so this angle is a right angle. And we define the intersection point between the perpendicular from point A and the perpendicular from point C as point E. So we actually created here quadrilateral ABCE. In quadrilateral ABCE we have 3 right angles, 1, 2, 3, and we define this angle as angle X, and we have the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. That is to say, the sum of three angles, that is 270 degrees, plus the size of the fourth angle, that is angle x. In total, the sum of those four angles must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation, and we got that angle x equals to 360 degrees minus 270 degrees. It is actually 90 degrees. So we found out that this angle is a right angle. Therefore, all angles inside quadrilateral ABCE are right angles. Therefore, we can relate to quadrilateral ABCE as a rectangle according to rule number 2. Then we have rule number 3, that the opposite sides of a rectangle are equal to each other. It means that the opposite sides of rectangle ABCE are equal to each other. That is to say, AB equals to EC. AB equals to EC according to rule number 3. But it is given us the question that AB equals to 4 units. AB equals to 4 units. From this equation, we will derive that CE also equals to 4 units, or EC also equals to 4 units. EC also equals to 4 units. Likewise, according to rule number 3, CB equals to AE. CB equals to AE, and if we define CB as x, if CB is defined as x, then from this equation we will derive that AE also equals to x, so AE also equals to x. And it is given us in the question that CB equals to AE. It is given us in the question that CB equals to AD. And we have already found out that actually CB equals to x according to our definition from one side, and from the other side it is given us in the question that CB equals to AD. So from this equation we will derive that AD also equals to x. AD equals to x. So what is the size of this angle, angle EAD? Angle EAD must be equal to 90 degrees minus this angle that is 30 degrees. 90 degrees minus 30 degrees is the size of this angle. That is to say, this angle, angle EAD, equals to 60 degrees. Then I copied triangle EAD in a new page, and we analyzed triangle AED that has two equal sides. AD equals to AE equals to x. Okay. We have here triangle AED. We know that AE equals to AD equals to x. Angle EAD equals to 60 degrees. And we know that in front of equal sides in the triangle there are equal angles. Those two sides are equal to each other. Therefore, they are located in front of equal angles. That is to say, those two angles that are located in front of equal sides must be also equal to each other. So if this angle is y, this angle will be also equal to y. And we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, y plus 60 degrees must be equal to 180 degrees. Y plus y is 2y, so 2y plus 60 degrees must be equal to 180 degrees. We subtracted 60 degrees from this equation, and we got that 2y plus 2y equals to 180 degrees minus 60 degrees, 2y equals to 120 degrees. We divided this equation by 2, and we got that y equals to 60 degrees. So here y equals to 60 degrees and y equals to 60 degrees. Therefore, triangle AED is an equilateral triangle. It means that ED also must be equal to x, because all of its sides must be equal to each other, and all of its angles, they are equal to 60 degrees. So we can write down that ED equals to x, and this angle equals to 60 degrees, and this angle equals to 60 degrees. What is the size of this angle? This angle will be equal to 90 degrees. That is the size of angle AEC, minus this angle that is 60 degrees. 90 degrees minus 60 degrees is 20 degrees. Is 20 degrees. 90 degrees minus 60 degrees is 30 degrees. And 30 degrees is the size of an LDEC, the size of this angle. Then we prove that those two triangles can go into each other. Why those two triangles can go into each other? First of all, AB equals to EC equals to 4 units. AB equals to EC equals to 4 units. Angle BAD equals to angle CED equals to 30 degrees. Those two angles, they are equal to each other, they are both equal to 30 degrees. And AD equals to ED equals to X. AD equals to ED equals to X. So we proved that triangle ADB can go into triangle EDC according to side angle side rule. From the fact that those two triangles can go into each other, we will conclude that CD equals to DB. CD equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. But CD equals to 2 units. It is given us in the equation. From this equation we will derive that BD also equals to 2 units. BD equals to 2 units. Then I drew triangle ADB in a new page, and we implemented the law of cosines in this triangle, triangle ADB. So this is triangle ADB. We know that AD equals to X, this B equals to 2 units, AB equals to 4 units. According to the law of cosines, in triangle ADB, cosine 30 degrees equals to X squared plus 4 squared minus 2 squared over 2 times X times 4. Here 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12. So in the numerator we have X squared plus 12. In the denominator we have 2 times 4 is 8, 8 times X is 8X. Cosine 30 degrees is square root of 3 over 2, and it equals to X squared plus 12 over 8X. We multiplied by 8X this equation, and we got that square root of 3 over 2 times 8X equals to X squared plus 12. 8 over 2 is 4. So we got that 4 times square root of 3X equals to X squared plus 12. And actually 12 is 2 times square root of 3 squared, so we can substitute 12 by 2 times square root of 3 squared, and we will get that X squared plus 2 times square root of 3 squared minus 2 times X times 2 times square root of 3 equals to 0. This expression is very similar to the algebraic identity that A squared plus B squared minus 2 times AB equals to A minus B squared. So we can substitute our specific expression by A minus B squared. Here in our specific expression, A equals to X and B equals to square root of 3 squared. So A minus B squared will be equal to X minus 2 times square root of 3 squared, that equals to 0. We took a root out of this expression and we got that X minus 2 times square root of 3 equals to 0. We added 2 times square root of 3 to this expression, and we got that X equals to 2 times square root of 3. So here we can write down that X equals to 2 times square root of 3, X equals to 2 times square root of 3, and X equals to 2 times square root of 3 units, and X equals to 2 times square root of 3 units, and the area of triangle ABCD equals to the area of triangle ADB plus the area of triangle DBC. We calculated the height of triangle ADS. We drew a perpendicular to AB. We define the touching point between the perpendicular and AB as point S. DS is defined as edge. Sine 30 degrees in triangle ADB equals to edge over 2 times square root of 3. Sine 30 degrees equals to edge over 2 times square root of 3. Sine 30 degrees is 1 over 2, so 1 over 2 equals to edge over 2 times square root of 3. We multiply this equation by 2 times square root of 3. And we got that edge equals to 2 times square root of 3 over 2. 2 over 2 is 1. So we found out that edge equals to square root of 3 units. Now it is very easy to calculate the area of triangle ADB, because of the fact that the area of triangle ADB equals to the base, that is AB, times the height, that is edge, over 2. AB equals to 4, edge equals to square root of 3, so all divided by 2. 4 over 2 is 2, so we found out that the area of triangle ADB equals to 2 times square root of 3 units. And then we calculated the area of triangle DBC according to a special formula. We found out the semi-perimeter of this triangle, triangle DBS. The semi-perimeter of the triangle equals to the perimeter over 2. The perimeter is 2 plus 2 times square root of 3. And if we divide the perimeter by 2, we will get the semi-perimeter. So the semi-perimeter of triangle DBC equals to 2 plus 2 plus 2 times square root of 3 over 2. That is actually 2 plus square root of 3. So we know that S equals to 2 times 2 plus square root of 3, A equals to 2, B equals to 2, and C equals to 2 times square root of 3. We put the data inside this equation for the area of triangle DBC. The area of triangle DBC equals to the square root of S times S minus A times S minus B times S minus C. S equals to 2 plus square root of 3 units. S minus A is square root of 3, S minus B is square root of 3, and S minus C is 2 minus square root of 3. So square root of 3 times square root of 3 is 3, and 2 plus square root of 3 times 2 minus square root of 3 is, we calculated the value of this expression according to the algebraic identity that A plus B times A minus B equals to A squared minus B squared. A is 2, so A squared is 4. B is square root of 3, so B squared is square root of 3 squared, that is 3. So here we got 4 minus 3 is 1. 1 times 3 is 3. So we got that the area of triangle DBC is square root of 3 units. And the area of quadrilateral ABCD will be equal to the area of triangle ADB, that is 2 times square root of 3 square units, plus the area of triangle DBC, that is 1 times square root of 3 units, and 2 times square root of 3 units plus 1 times square root of 3 units, it is 3 times square root of 3 square units. So we found out that the area of triangle the area of quadrilateral ABCD in both methods, it equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay, thank you very much.